Hey Bytemonks! In my previous video, I explained why REST APIs have become the standard for building web services. They are lightweight, scalable, and easy to use. In this video, I'll break down the top and must-know best practices when designing and implementing REST APIs with Java examples. So let's get started. First of all, use HTTP methods correctly. Now, I have already explained and covered them in depth in my last video. In short, think of these as the verbs of your API. They define the actions you're performing, so you must adhere to the semantic meaning of HTTP methods. Get is to retrieve data and should be always idempotent, meaning multiple identical requests should have the same effect as one. Post is to create a new resource and is not idempotent. Put is to update an existing resource entirely, which is always idempotent. Patch is to partially update an existing resource, which is not necessarily idempotent. And delete is to delete a resource and is always idempotent, because if you delete the same resource 10 times, it's going to have the same effect. Next, let's talk about how we structure our URLs, or URIs to be precise. In REST APIs, we use URIs to identify resources. The key thing to remember is to focus on things, not actions. So instead of describing what you are doing, you describe what you are working with. So you must avoid actions in URIs and focus on resources and use hierarchical URIs for nested resources. The key here is to use nouns for your resources and avoid putting actions directly into the URLs. Think about it this way. The URL should represent what you are working with, and the HTTP method tells you what you are doing with it. So, for example, /customers is good. That represents the resource customers. Then you use get to retrieve customers, post to create new ones, put or patch to update them, and delete to delete them. On the other hand, URLs like /getCustomers or /createUsers are bad practice. They are redundant because the HTTP method already tells us what action is being performed. Also, if you have nested resources, you use hierarchical URIs. For example, /customers/123/orders to get the orders for a specific customer. Now, let's talk about status codes. These are super important for communicating the outcome of a request to the client. In Spring, response entity class controls the whole response. Response entity.created is 201 created, response entity.ok is 200 ok, and response entity.notfound is 404 not found. It's how we build correct REST responses. And here are some of the most common ones. 200 OK is for success when everything goes smoothly. 201 created is when a new resource was successfully created. 204 no content is when the request was successful, but there was no content to return in the response. 400 bad request means the client sent something that the server couldn't understand, like invalid input. 401 unauthorized is for authentication is required to access this resource. 403 forbidden is when the client is authenticated but doesn't have any permission to access the resource. 404 not found is for the requested resource could not be found, and 500 is when something went wrong on the server side. Moving on to error handling, that is when things do go wrong. It is crucial to provide clear and descriptive error messages in a consistent format, and this helps our clients to understand what happened and how to fix it. This code here shows how to do it globally in Spring. Using add_rest controller advice, we can catch resource not found exceptions. So instead of letting the application crash or sending back cryptic messages, we create a clear error response with a 404 not found status. This gives clients the information they need to understand what went wrong and how to potentially fix it. So good error handling makes your API more user-friendly and reliable. We also want to validate requests. That is using frameworks like Hibernate Validator in Java to make sure the data coming in is what we expect. This code snippet here handles creating new users in our Spring API. The add_post mapping annotation defines this method as a handler for post request sent to the /users endpoint. The add_valid and add_request body annotations ensure the incoming user data is valid and comes from the request body. The code also calls userservice.saveUser. It's likely persisting the user data. And if successful, it constructs a response entity which sets the status code to http status.created. informing the client that a new user was created. Next up is versioning. As your API grows and changes, you will need to update it. But how do you do that without breaking existing apps that rely on the old version? The answer is versioning. It lets you introduce new features or changes while keeping older versions available. And there are two main ways to do this. URI versioning like /v1/customers and /v2/customers, or header versioning using a customer header like accept version v1. Let's first talk about URI versioning. This is the simpler approach. You just include the version number directly in the URL. For example, /v1 here would access version 1 of the customer API, while /v2 would access version 2. See how we have two separate controllers, one for each version. This keeps things nicely separated. The second approach is header versioning. Here, the version is specified in custom HTTP header, like accept version. For example, a client would send a request with a header accept version v1. This is a little more complex to implement, but it keeps your URLs cleaner. And here is an example with Spring Webflux. Here, both methods have the same URL, but are differentiated by the accept version header. This approach is more flexible, but requires a more complex setup. Now, when your API deals with tons of data, sending it all at once can be a nightmare. That's where pagination, filtering, and sorting come in. Pagination breaks the data into smaller, manageable chunks like pages in a book. Filtering lets clients narrow down the results to only what they need. And sorting lets them organize the data in a specific order. Let's start with pagination. Imagine you have millions of users. You wouldn't want to send all of them in a single response. Instead, you would send them in pages. Here is a simplified Spring example using Pageable. Here, the add request param annotations let clients specify the page number and size of each page. Spring Data JPA then handles the pagination for us. We get back a page object that contains the current page of users, as well as metadata like total pages and total elements. Now let's talk about filtering. Suppose clients want to find users by name. We can use query parameters for this. If the name parameter is provided, we use a custom query method to find users whose name contain the given string. Otherwise, we return all users. Finally, sorting. Clients might also want to sort users by their registration date. And again, we can use query parameters. Here, if the sort by parameter is provided, we use Spring Data Sort to sort the results accordingly. A more advanced concept is HATEOAS, or Hypermedia as the engine of application state. It's all about including links in your API responses that guide clients on what actions they can take next. It makes your API more discoverable and easier to use. Let's look at simple Java example using Spring Boot and Spring HATEOAS to illustrate how you might include these hypermedia links in your responses. So here in this code snippet, we have a simple book controller with two endpoints. The first one retrieves a single book by its ID, while the second one retrieves all books. Notice that in our getBook method, rather than returning just a book object, we are returning an entire entity model book. This special wrapper from Spring HATEOAS allows us to attach links to our object. So when a client calls getAPI/book/1, a typical JSON response, courtesy of Spring HATEOAS, might look like this. So what's happening here? Entity model book wraps the book resource to include links. Self link points to the current book, that is /book/1, and all books link allow the client to discover the endpoint that returns all books, which is /books. By embedding these links, the API effectively guides clients on possible next actions, making your service more intuitive and self-documenting. Finally, and very importantly, security. Use HTTPS for encrypted communication and implement authentication. Methods like OAuth 2.0 or JWT are common, and use authorization to control who has access to what. Spring Security is a popular choice for this in Java. And for in-depth explanation of various API security concepts, do check out my security playlist in the description. Each video focuses on a specific topic, so you can easily find what you're looking for. And I hope you'll find them interesting and helpful as others have. So, those are some of the key best practices for building REST APIs. Remember, these are guidelines, and you should always adapt them to fit your specific needs. But following these principles will help you create easy-to-use web services. I'll see you in the next video.